So as I'm recording, if you go on to show my homework, most of you I know have already looked at this particular task, so well done for those of you who've done that. So you're logging into Zoom, which you've done. We're going to do some revision work. So once we've finished, you've got some attached revision material. That's down here. That's under revision moments and pressure. It's a PDF document that you can use to do some revision of what will be in this the second half of the lesson sort of task. So what we're going to do is we're going to go through some of this revision material in the lesson today. It'll be about half an hour from me teaching. It doesn't mean that I'll then go off and have a cup of coffee. That means that if you've got questions, obviously please do ask. Ping me an email, or you can send a comment to me to ask a question. And also at the end of my sort of talky bit, our discussion, I'll then obviously give you a chance to ask any questions if there's anything sort of immediately burning that you want to know about. So I hope you can all hear me. So we'll start off with the revision. So sorry, just to finish off, the last bit is to have a go at a test. Now this should be about 45 minutes, but if you want to take longer, please do. I want to see what you can do, not how quickly you can do it. And if you're completely stuck with the test, have the revision material in front of you that you can use to recap anything should you need to. In terms of how to answer questions, well, that's part of what this session is about. Now, when you submit your answers to your test, you can write it by hand on a piece of paper, take a photo and submit it to me, submit it as a picture file or as a PDF. But I've also given you on your download list an answer paper, which is just a Word document with the questions already written down on there. So with the question numbers already written down. So it gives you another way of submitting answers if you find that easier to do. At the end of the day, I'm trying to make it as easy as I possibly can for you. But I would like you to make sure you get this done because we're moving on to the thermal energy topic next week. So we've got that's what we're going to do. Now, if you are at home and you've got a printer, that's wonderful. You can actually print out the paper itself, so you can download the paper, the test paper itself, and you can print it out, complete it, take photos of your completed work, and just send it to me via the submission on Show My Homework. But what I wanted to do really today was just to show you what I've given you and what I'd like you to do, and also take you through how to answer some of the questions, just to give you a bit of a reminder and a little bit of a warm-up. So if I go back to stopping sharing, there we are. So if you look at your pack, if you look at what I've given you some pages from a revision guide. Now switch camera. So you've got a page on moments, that's also turning effects and levers and seesaws. It gives you all the key facts you need. You've got a page on pressure to do with force divided by area. That's a key formula that you have to remember. You have to remember your units. The Pascal, for example, is a unit of pressure if your area is in square meters and your force is in newtons. Otherwise, it's the unit of force divided by the unit of area.
I have a question.
Yep.
So what's the formula for pressure? It's
for pressure. The one to remember is pressure is force times is force divided by area. Now this is on the sheets that I've sent you, so you can always have another look. What I've advised is before you have a go at the test, spend at least 20 minutes really going through the revision material. It'll just help you to be reminded of what we learnt last term. So, for example, if you want to calculate force, you cover up force on the triangle, and we know it's pressure times area. If you want to calculate the area, if you know the force and pressure, then that's force divided by pressure. Okay? Okay?
Wait, do you have our notebooks?
I have your notebooks, unfortunately, but which is why I've given you this information here. It should give you pretty much everything you need to be able to do the
for the test.
To be able to do the assessed activity. I'm not going to call it a test, although I've called it a test on Show My Homework. Actually, this is an assessed activity. So all it is if you can't remember it all, don't worry. Use the pages that I've sent you and it should give you enough to be able to do nearly all of this. Okay.
All right, but do we do that on a separate piece of paper?
Yeah, I've already explained that if when you get the test, all you need to do is just is either print out the test and you can work on it, and then take photos of your work and send it to me, or you can write your answers on a separate piece of paper, make sure the questions are clearly labeled so I know which questions you're answering, or you can use the Word document that I've attached if you want to type your answers in. That's absolutely fine. Is that okay? Is that all right?
Yeah.
Okay.
Yes.
Okay,
Yeah.
lovely. Right, so let's move on. So you got a page on moments, a page on pressure, on calculating pressure, and then you've got a second page on pressure, which reminds you about the idea that the deeper you go in a fluid, whether it's a gas or a liquid, the more pressure, the more of the fluid there is above you, so the pressure will actually increase. So there's a little bit of a page to read there, just to remind you of what we've done. This is just reminders, so that you can have a go at the questions. The main focus of this lesson really is just to take you through the practice questions. Now, as I said, I am recording this. What will happen is after the video session, I'll then convert the recording into a video file, which I will post up for you within about half an hour or so. And so if there are bits you want to remind yourself about, if you want to watch this video again, you can watch it again. It's obviously also for those who couldn't make it to today's lesson. So we've got a single hole punch here. It's somebody called Stuart is using a hole punch. So in sort of the assessed material, you get given a context or an application, and it says as he presses down on the handle, the cutter, which is here, makes sort of makes a hole in some paper. You know what a hole punch is. So the first thing is to calculate the moment or the turning effect of the 6 newtons. So we've got here a 6 Newton force, and it's 8 centimeters away from the pivot. So we know the moment. So as I'm writing my answer, if I was writing this as an assessed piece of work, I would actually write the question. I'll then write the formula. The moment is force times the distance. So the force it said here is 6 newtons multiplied by the distance. Well, I'm going to keep it in centimeters. I could convert that to meters, but I don't think I need to. So what I need to do now is just put do my calculations. 6 times 8, which even with calculations where you could do it by mental arithmetic, I always recommend the use of a calculator.
48.
Is indeed 48. Well done. Remember my units, because the question says give the units. So my units, well, I've got newtons and I've got centimeters. So it's Newton centimeters. And then I double underline my answer, so it's really clear what my final answer is. So if I do part B, the moment makes the cutter press down the paper, you have to calculate the force with which that cutter is pushing down the paper. So what you've applied here is a clockwise moment, and we're working against the paper, so it needs to provide an equal and opposite. Paper's going to provide an equal and opposite moment. Okay, so if we go into part B, I'll just move up a bit. Go into part B, we can calculate the force, because we know moment is force times distance. And we want to calculate the force, so we calculate the force. We rearrange this. Force is going to be moment over distance. So the moment we calculated before was 48 Newton centimeters, and because we kept it in centimeters, this is 0.5. So divided by 0.5 gives you 96 newtons. 48 divided by 0.5 is 96 as your answer there. Okay, so then C is a pressure question. It says the area of the edges of the cutter is 0.00001 square meters. Use your answer to B to calculate the pressure of the cutter on the paper and give the units. So if we've got the area there, we know for part C, we know that the pressure is force over area. You might know it as the triangle. And I want to calculate the pressure. So it's force over area. So if we calculate the pressure, that's going to be the force, which we calculated before, was 96, divided by the area. Well, the area here, it tells you, is 0.0001. So write it down, make sure it's clear. 4 zeros plus the one before the decimal point. And then all we do really is we just calculate it. So 96 divided by 0.012341 gives me 9,600,000. And that's going to be, well, we've got to be careful. If the force is in newtons, the area, it tells you, is in meters squared. So it's newtons per meter. So that would be pascals. Okay, that makes sense?
Yeah.
Okay. So the next one to do is somebody called Martin's mother. There we are. There we are. Martin's mother wears shoes with a pointed heel. After she's walked across the floor, Martin notices her heels have left dents in the floor. Martin didn't leave any dents on the floor in his trainers. Martin weighs 700 newtons. His mother weighs 600 newtons. Explain why his mother has dented the floor even though she weighs less. So this is an explanation. Explain means to say why. So the first part of the explanation, well, if the clue is to do with the shoe. She's got a pointed heel. So the pointed heel is going to be, it's going to be less area. Pointed heels, heels have less area on the floor. Ari, you've sent a little, you sent a direct message to me asking if I can send a pic of this later. Well, what I'll do is I'll send you the video so you can actually watch the video, and that'll give you everything. Okay, is that okay, Ari?
Yeah.
Okay. So the pointed heels have less area in the floor. Obviously, as pressure is force over area, if area is a small number, the pressure is greater. So that means, or implies, a greater pressure on the floor, which is why she makes dents. Okay, we saw that video last term showing how smaller how people with smaller shoes, smaller soles on their shoes exert a greater pressure. In fact, you actually calculated the pressure of your shoes on the floor. So the next part is each of mother's shoes heels has an area of 0.0001 square meters. She leans back on her heels, so all of her weight acts through them on the floor. So remember, this is going to be 2 heels because she's got 2 feet. We're going to assume that mother is human being, is a human being, and it's not, and it's got both of her feet because it says each of her heels, so it's more than one shoe. She hasn't got 4 legs or anything like that. Calculate the total pressure the mother's putting on the floor when she's standing on 2 feet and show you're working. Now it says show you're working and it's 3 marks. So you've got to be very, very careful to show clear working. So the first part is to start with the formula. Pressure is force over area. So the force is going to be the mother's weight. Remember, you calculate when you measured your pressure on the floor, you calculated your weight from your mass. But here, you're given the weight straight away, 600 newtons. So the force is 600 newtons. The area, where's the area of each heel? So each heel is 0.0001 square meters. So it would be 2 times 0.0001 square meters, which is 0.0002 square meters. Okay, so that I've got the reasoning there, the reason that there are two feet, therefore 2 heels, and that would be therefore the area. Then you substitute. Pressure is a force, which is 600, divided by 0.0002. Always use a calculator. Why? Because sometimes even when you do something you think is simple by mental arithmetic, you can make mistakes. Calculator makes it a little bit easier to use. So it's 3 zeros after the decimal point and then 2. And we end up with 3 million pascals. And then just write the answer. Okay, double underline. And that is the total pressure mother's putting on floor when she's standing on 2 feet. Okay.
So what's the formula for area?
For area, well, if you want to work out the area, usually in questions you're given it, but basically if you have to calculate an area, remember when we were doing pressure, usually an area is breadth times width. So if that was, say, 3 centimeters and that was 4 centimeters, that would be 3 times 4, which is 12 square centimeters. That makes sense?
Yeah, thank you.
That's a way of calculating area. Normally in questions, you're given the area. Just be aware of the unit. If you've got an area in square centimeters, then when you calculate your unit of pressure, that's going to be newtons per square centimeter, not pascals.
But what about the one in the triangle? If you want to find area.
You want to find the area? Well, if you want to find the area, if you know the force and the pressure, you just cover up the area on the triangle. It's force divided by pressure.
Okay.
It depends how you're trying to calculate an area. If you're given a length and a width, or you're given a shape on square paper, you know that you have to calculate the area using basic sort of geometry. If you're wanting to calculate the area and you're given a force and a pressure, you know it's going to be force divided by the pressure.
So if you want to find the force, would it be pressure times area? That's
correct, yeah, because you cover up force, they're next to each other, so it's pressure times area. Well done, that's good.
Oh.
Okay, any other questions about that? That was a good question, thank you, both of you. Okay, let's move on to the last part, okay? I think we're actually a little bit ahead of schedule. That's probably a useful thing. So if we go to question 4 says that after taking in air, dolphin swims slowly downwards towards the seabed. What effect will this have on the water pressure felt by the dolphin? Remember that when you go sort of down under any fluid, be it water, be it air, the further down you are, the height of the fluid above you is going to result in increased pressure. If we think about it, if you've got the surface of the water there, there's your air above it, there's your water. If you've got your dolphin, now I can't draw dolphins very well, I have to excuse my slightly dodgy drawing. Okay, there's a dolphin. Okay, now what happens is you've got the weight of the water is pushing down on the dolphin. The more water there is above the dolphin, you remember there's going to be more force, and fluid pressure actually acts in all directions. Okay, so when you've got the fluid pressure there, then you've got an increased pressure. So the further down you go, the more pressure you'll feel. Have any of you ever swum underwater?
Yeah.
When you go down deep, you notice the pressure on your ears.
Yeah,
sometimes.
Yeah, so that's actually the water pressure pushing on your ears. In fact, if you're scuba diving, I'll just switch to my webcam. If you're scuba diving with an air supply, sometimes you go very, very deep. Now, as you do that, it starts to put pressure on your ears, and it can become very, very uncomfortable because you go so deep the water pressure is actually pushing on every part of your body, including your eardrums, which are sensitive. So what you have to do sometimes, you pinch your nose and gulp, or pinch your nose and blow, like that, and it equalizes the pressure between the air behind your eardrum and the water pressure pushing on your eardrums, and equalizes and makes it more comfortable. You may also notice it when you go up in a plane. If you think about it, you go up in a plane, there's less weight of air above you, so there's less air pressure. So as you go up and down in a plane, you sometimes feel your ears sometimes go a bit funny. That's why some people can't hear very well, either when they're on a flight or when they've landed. They sometimes can't hear that well. So because you can't hear that well, that's because there's an unequal pressure, which is why when you land, people say you should pinch your nose and gulp. And what that does, it opens little sort of canal behind your eardrums that's at the back of your mouth, and it equalizes the pressure so that your eardrums balanced again, so that it can vibrate properly. Otherwise, it's like your eardrums sort of stretched like a balloon, and it can't vibrate as well when sound waves hit it, which is why your hearing goes funny. Okay, so lots of examples of it. As you go in a plane, you sometimes, if you're given a box of Pringles or a bag of crisps, if you've still got that bag of crisps when the plane's got up to a high altitude, even though the cabin's pressurized a little bit, there's less air pressure, and that bag sort of expands a bit, and it sometimes looks like there's lots and lots of air in it. Same amount of air, it's just taking up more space, more volume. Okay, so if we go back to our question, what effects will it have on the water pressure? Oops, go back to my desk camera. So it's just 1 mark. So we don't want, it says here on the question here, we've got just 1 mark here. So we don't have to worry too much about massive amounts of detail. It just wants what effect it has. Well, the pressure increases. Okay. So then we go on to part B of our example questions. So the dolphin releases a bubble of air which rises to the surface. What force causes the bubble to rise? Now, this is a sort of going back to previous years. You've done forces for a couple of years now in science. I don't know who your G is, but you've just arrived, so welcome. We're just going through some questions. You might want to sort of have a look at the video of this session after I've posted it. So the pressure will increase. It was part A. Part B on the example question is what force causes the bubble to rise? Well, it's a thing called upthrust. Now we can link upthrust to pressure, because if we think about it, we've got water, and this is now part B part 2 really. If you've got air, you've got water, you've got your air bubble down here. Now you've got pressure here, and you've got pressure here. But this pressure here is going to be greater because it's further down. So the pressure of the water pushing here is going to be less than the pressure of the water pushing here, which means you've got a net upward force pushing upwards. Does that make sense? So where it says draw a force diagram for the bubble as it rises to the surface, okay. So what you'd have is you'd have the upthrust pushing the bubble upwards, okay. Does that make sense?
Yep.
Okay, so that's the basic idea as to exactly why, why an air bubble rises to the surface, because there's more pressure at the top than there is at the bottom. It's also the fact that the air bubble is less dense than the water. Okay. Right, any questions about that? Does that make sense?
Yep.
So the first thing, so what I'd like you to do, your first sort of task is revision. And that's using sheets, using the, oh dear, I must spell it correctly, Mr. Chalmers. Using the sheets, okay? Now, when I say revise, it needs to be active revision rather than passive. Passive revision is just reading the sheets, which is useful to start off with, but actually what you should be doing is either making some revision notes on a piece of paper, a piece of scrap paper, or as I've shown you before, mind mapping, okay? Do you all know what a mind map is? Do you remember what a mind map is?
Yep.
Yeah, so it's the idea that we looked at two particular parts. We looked at pressure, we looked at density, we looked at moments. We knew that each of these has an associated formula. Pressure is force over area. We know density is mass over volume. Okay. We know that moments is force times distance. And we also know that for equilibrium, clockwise moments equals anti-clockwise moments. Okay. Does that make sense?
Yeah.
These are all things that you need to make sure that you've quickly recapped. Okay. As I said before, the first thing, your first port of call really should be to go through the revision material. I think by the time you've done a mind map or a list of notes based on the revision material, I should have the video up and running for you to watch again if you need to. And you might want to use that again to go through the practice questions at the end of your at the end of the revision material, just to remind yourselves as to the techniques you need to use when you're answering the questions, and then you can download and have a go at the test. As I said before, although I've called it a test, if you want to use your notes, if you want to use revision notes, if you want to look things up while you're doing it, absolutely fine by me. I want to see what you understand, not just what you can memorize or how fast you can write, okay? Take the time you need to actually make sure you get the test done, and do try to and do your best with it. I'm going to award an extra few marks on the test for putting in a decent attempt. Before I finish, can I just ask whoever logged in as your G, could you please tell me who you are?
Chris.
Sorry, who's your G?
It's Christopher. It's Christopher.
Christopher, right? Okay, because I need to make sure that anybody who's not present is written to make sure that they're engaging with the work. Okay. So, are there any other questions? Is there anything else you want to ask me?
No.
No. Okay, so what I'll do is I will end the meeting. What I'll do is I'll turn my video off, but I'll stay on the on Zoom, so that if you want to sort of log into Zoom again, back into the meeting to ask me anything, then you can do so. Okay, so I'll stay on for probably about another. Well, I'll come off it and then come back on for the rest of the lesson. Is that all right?
Yep, thank you.
Okay, I'll see you guys. If I don't see you before, I'll see you next week. And what we'll do next week is we'll do I'll start with a walkthrough of the test that you're going to have a go at today. Okay.
All right. Thank you, sir. Thank you, sir.
See you.
Bye.